Okay. Hello, good morning, good evening. So this is Arun Kumar Rajaganapati with MSEA course and Ankur Bhagat.
Yeah, myself like Ankur, I'm also one of the project mate for Arun.
So we'd like to just demonstrate something on the probability and statistics final team project specifically for this fall. And we took the data set for landslides and associated casualties across the globe and specifically with emphasis on India. So we completed some internal assessment, which we would like to just demonstrate to you. So at high level, uh, the landslides, it is one of the major casualty across India. So with the recent tragic event, whatever has occurred in Wayanad, Kerala, that was the predominant triggering factor for us. Instead of taking other data sets, we thought this data set would make some significant impact, or if at all, if it will be useful. So in terms of the data set wise, so what we did is we took the data set directly from the NASA website. Um, However, there are other data sets that were available as well. Um, we did some exploratory data analysis. We just trimmed the data set or updated data set, found the specific cause. So there may be other factors which will be contributing to landslides. So we restricted our study to specifically only around um, the country as India, and then in terms of rainfall or other measures, whatever associated rainfall like monsoon, cyclone, and all those things. But this project or the study can be again extended further based on vegetation or the soil quality or the topography and elevation, or specifically on the seismic activity in terms of earthquakes, um, so that it can be extrapolated. And this study can further be extrapolated with some sort of a neural networks and other further study as well. Uh, yeah, anything could you want to add?
No, that's it. It's fine. Yeah.
Yeah, so in terms of data set wise, maybe let me just go here. So we will just see directly at the data set. Um, easy slow. So in terms of the data set wise, what we did is one data set that we consider, it is directly from the frequency distribution. I mean the overall state rainfall level, because there are many data sets that are available across multiple statistics website, our Indian Statistics Institute website and all those stuffs, and from meteorological department. However, the data set that we have, base data set from NASA, is from 2007 to 2016. So we didn't kind of, we are also aware, we are cognizant of the fact the rainfall and all those things. It should be taken specifically for those landslide geo with specific coordinates or the geo coordinates that would be more appropriate or specific. But in this case, we could not get that uh, precise rainfall measurement. So what we did is we just extrapolate, we just presumed the state normal between whatever our meteorological department has published from 1970 to 2001. So, and then we tried to find a correlation between this. So, jumping on to this one, um, maybe Ankur, you want to just start, or I will just stall, or you'll start. So, on the data set.
Okay. So basically, this data set has been referred from the NASA data sets, right? And this data set contains various columns related with the source name and what kind of events it has uh, occurred, or like what kind of category it was, whether it was a landslide, and what was the reason for that landslide related with that, which region it belongs to, uh, and the dates, created date, and latitude and longitude. It has been presented in that way. So location accuracy is also being provided across that one, like within how much kilometers the uh, effect was being present. Yeah. So
Yeah. So in addition
so
to that, just to add what Ankur has mentioned, so even date and geo coordinates were mentioned, but it is missing the elevation data set. So what we tried doing is we tried fetching the elevation data set across by other Python packages or through uh, another iSet website, NASA's package, which is licensed by MIT. But in some cases, the latitude and longitude is not precise, so it is not fetching the information. So that's the reason we had to abandon the elevation or topography information. So that is something that we couldn't plug in. And similarly, based on this coordinates, we could not get the precise rainfall data set. That is another reason that we had to just miss it. But we found a way to extrapolate it. So coming to this data set, right? So this is how the list of columns and then the associated data types, how it looks like. So we just added month and year to that, in addition to the longitude and longitude based on the event date when it occurred. So in the exploratory data analysis part, we just did some additional data update. So maybe you want to talk about this chart, Ankur?
this is being presented using Plotly, and across different regions, uh, how many number of fatalities has happened due to landslides. So what are the different causes? Based on that, it has been created this uh, map view of the fatalities. So you can see like across Nepal, India, and like Afghanistan, India as well, Sri Lanka as well. So measure of the hilly areas, like you can see like towards the Himalayas and towards like towards that Bangladesh, Myanmar, like near to the sea and hilly areas, you can see the number of landslides could be more, and there you can see the fatalities has been increased or like has been predominant over that area.
Yeah, and then in addition to that, precisely maybe the Western Ghats as well as maybe the Himalayan regions, maybe the floodplains towards northeast are rainy regions. So this is what it is, specific to India. But the thing is, like there are other countries as well. So for whose topography we are not aware, but we just plotted it for our thing. But at high level, so you can see here, the Taiwan fatality count seems to be too high, and somewhere around Philippines it is too high. So we recorded this, but this is across the years of the overall data set that we have. Same thing that we presented in a different format, the dark matter graph. So out of this, could you want to add what are the causes of trigger?
So there could be different causes for the trigger, like construction, like dam embankment collapsing, or leakage pipe, or like rainfall. So these are the major things causes. Based on that, we have drawn a bar chart which is reflecting the total number of fatalities due to that cause. So you can see one of the major thing is like downpour and the rainfall, and the cyclone. Third is the cyclone. So that's what it showcase using this graph. Yeah.
Yeah, thanks, Ankur. Yeah, so as Ankur mentioned, so this is the overall across the globe. What are the causes of major landslides based on the data set that we took? So of course, the seismic activity at the earthquake is very less, whereas the downpour or the rain seems to be more. So what we considered is, out of this data set, we again further refined it. Whatever that we see here, the fatality count by rainfall is more. So we constructed a box plot across countries in terms of fatalities. We are able to add some in terms of top term, but the thing is like overall fatalities across globe, we just updated it yearly fatalities. So over a period of time, it is somewhat consistent. But 2010, we have seen a huge spike, and injuries over a period of time is increasing. 2015 seems to be having a huge spike in terms of yearly trend. So what we did is we just restricted specifically to India on this data set, and out of India data set, as you can see here, total fatalities by year. 2010 there was a huge spike, and 2016 in terms of injuries there was a huge spike. So this is something that we just updated it for various reasons. Um, and then with respect to the monthly distribution, as you can see here, the fatalities and injuries are more in terms of July and August. both in terms of fatalities as well as injuries. So this may be a concern to the government, probably like
Maybe mostly due to the rainfall during June and
yeah,
July, it will be
maybe the
high.
monsoon season or something, and then or end of summer, which
Yeah.
is the glaciers are melting or whatever it is. So so overall, the same distribution as you can see here, the monthly count, the injury count, it is more for July and August. And similarly, we try doing a plotly or a 3D plot diagram uh, across all countries. So there is one specific outlier, which is Jammu and Kashmir, which has a fatality of 435 on 2010. And there are other outliers as well. In terms of 2014, Maharashtra has a huge fatality. Other than that, the rest of the countries, rest of the states across the years are somewhat say, lesser. So we tried doing the same with the sunburst chart. Maybe you want to add code here. So
So as like Arun mentioned, like during 2010, Kashmir has a around 435 or 591 fatalities count during that time. So the sunbus chart depicts like each uh, region or each state, and it shows like how many number of fatalities it has happened. So across different. So another one is like Uttarakhand over there after just after Kashmir.
yeah. Yeah. So for 2010 seems to be the major event where in total fatality count is 591, out of which Kashmir and Uttarakhand both are like Himalayan regions, which has significant impact. And again, in 2014, Kashmir has a huge impact. So probably this is something as a concern for the team. So overall, like we just categorize it based on other trigger reasons. So predominantly what you observed is a rain, downpour, rain everywhere. This is the predominant continuous rain. So what we did is we just aggregated them into a single data set. So downpour, rain, snowfall, snow melt, all those things. We consolidated it as a rain because that was one of the triggering reason. We excluded all other man-made disasters like construction, mining, and all those things. So the local bodies can better handle it. Out of which, when you do a mosaic plot, so the rain is one of the predominant reason for fatalities. So this is what we observed. And in terms of the correlation or the p-values, whatever that we observed. So just to again further deep dive, what we did is we did the frequency distribution of our state normally fall directly from IMD website. So this is something that we mentioned earlier, that we took only at the state level because we could not get the precise information. So this is the overall correlation. And then as the plot indicates, when the rainfall is between like 1000 mm to 1500 mm, which is below normal for entire India, fatality or injury count is more. So this is something as a consideration that has to be taken. And this chart shows the overall landslide fatalities between aggregated value between 2007 to 2016. And then this shows like a time series map, like over a period of time, how it occurs and what are the significant events. So all this code is updated into the GitHub. Let me just quickly post the GitHub link. This is the GitHub link. Uh, Take a look. Right. Any concerns, questions? Thank you, Ankur. Thanks for all the help so far.
Thanks, Arun.
Thank you. And thanks to Professor Vinay, Dr. Vinay, and Dr. Zahid as well. Thank you.
Thank you.